This is SpaceTime Series 29, Episode 94, for broadcast on the 7th of August 2026. Coming up on SpaceTime, it turns out black holes are 100 times more powerful than previously thought, the dramatic collision which flipped our Milky Way galaxy, and a successful return to Earth for the crew of the Soyuz M28. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have been forced to rewrite their textbooks on the power of supermassive black holes after new observations have shown that these cosmic monsters can generate enough energy to impact galaxies hundreds of thousands of light years away. Scientists previously believed that the impact of winds generated by supermassive black holes was contained to the host galaxy. But the new findings, reported in the journal Nature Astronomy, reveals that the energy produced extends to surrounding galaxies 300,000 light-years away, 100 times further than previously thought. The study's lead author, Satoshi Yamada from Tohoku University, says the discovery demonstrates that these explosive winds impact vast expanses of space far beyond the galaxies they inhabit. Yamada says black holes are largely known for sucking in matter, but they also eject gas in the form of powerful winds. These winds were thought to be contained within the galaxy, but Yamada's study reveals that the force is immensely more powerful than previously understood. Yamada and colleagues used the XRISM X-ray Space Telescope to observe the activity of a quasar, catalogued as H1821 plus 643, located some 3.4 billion light-years away in the direction of the constellation Draco. Quasars are extremely luminous jets of energy and matter, given off by material being crushed and stretched in the accretion disk of feeding black holes. The rapidly growing black hole containing the quasar is located in the center of a galaxy cluster, where it's driving turbulence in the surrounding hot gas, emitting X-rays in the process. The authors precisely determined the motion of the gas by analyzing spectroscopic emission lines from iron ions. The observations revealed that the high-temperature gas surrounding the black hole isn't remaining static, but violently disperses over a wide area due to turbulence. And they also confirmed that the flow of the gas extends far beyond the host galaxy, reaching distances of more than 300,000 light-years. The amount of energy involved in the turbulence was approximately 100 times greater than what previous estimates had made, and equivalent to several billion supernova explosions, the blasts that occur when stars reach the end of their lives. Yamada says it's the first time anyone has shown that black holes can influence such a broad cosmic environment, and it demonstrates that black holes are key drivers of gas flows and motion in space, transporting vast amounts of energy and materials to very distant regions of the cosmos. This is SpaceTime. Still to come, the dramatic collision that flipped our Milky Way galaxy, and a successful return to Earth for the crew of the Soyuz M28 spacecraft. All that and more still to come on SpaceTime. A new study suggests that our home galaxy, the Milky Way, may have undergone a dramatic change in orientation following a head-on collision with another galaxy. The findings, reported to the Royal Astronomical Society's conference in Birmingham, help us explain a long-standing mystery about our galaxy. Using supercomputer simulations of galaxies like the Milky Way, astronomers found that galaxies with slowly rotating stellar halos are more likely to have experienced a major disk flip. That's where the galaxy's disk changes its orientation by more than 90 degrees. Most of the Milky Way stars are located in the flat spiral disk of the galaxy, and surrounding this disk is a much larger but sparser stellar halo, made up mostly of stars that originally formed in smaller galaxies before being pulled into the Milky Way through galactic mergers. Observations by the European Space Agency's Gaia mission have shown that the Milky Way stellar halo rotates very slowly, but astronomers have not understood why. So, they analysed the evolution of 25 Milky Way-like spiral galaxies in the Auriga suite of cosmological computer simulations, and they followed their development over billions of years. They found that galaxies with the slowest rotating stellar halos shared two important features. They each experienced a major head-on merger or collision with another galaxy, and they also underwent a disk flip during their evolution. The study's lead author, Kirill Batrikov from Durham University, says astronomers already know that the Milky Way had a massive head-on collision in the past with a galaxy known as the Gaia Sausage Enceladus, and this new data suggests that may have caused the Milky Way's disk to flip. The Gaia Sausage Enceladus was a massive dwarf galaxy that collided with and was absorbed into the early Milky Way somewhere around 10 to 11 billion years ago. This defining galactic merger was the largest single event in the early history of the Milky Way, and it reshaped our galaxy, leaving billions of stars orbiting in a highly elongated, sausage-shaped path. Identifying a past disk flip gives astronomers a new way to understand how the Milky Way assembled, and it may also provide indirect clues about the motion of its invisible dark matter halo. A disk flip also means most of the Milky Way stars moved on very different trajectories compared to the way they move today. Possibly even our own Sun, meaning our stable spot in the galaxy might not have been quite so stable in the past. The study also found that the rotation of the Milky Way stellar halo is closely linked to the rotation of its dark matter halo. And that suggests the two possibly evolved together as the galaxy grew by accretion of smaller satellite galaxies. This is SpaceTime. Still to come, a successful return to Earth for the crew of the Soyuz M-28, the red supergiant Antares, Barnard's star, the second nearest star system to the Sun, and the annual Perseids meteor shower are among the highlights of the August night skies on Skywatch. The Roscosmos Soyuz M-28 spacecraft has returned safely to Earth, bringing home the Expedition 74 crew who have spent the past 8 months aboard the International Space Station. The capsule touched down on the windswept Kazakhstan steppe 3.5 hours after departing the orbital outpost.
We are covering the return of the Soyuz MS-28 spacecraft with NASA astronaut Chris Williams and Roscosmos cosmonauts Sergei Kutsverchkov and Sergei Mikheyev returning under its main parachute, slowing it down for a touchdown on Earth. We did hear confirmation from the crew that everything was nominal or as expected on board. That's the Soyuz MS-28 spacecraft suspended under the orange and white parachute. That main parachute covering an area of 1,000 meters. It's slowing the capsule down to about 16 miles per hour. Quite a contrast from the 17,500 miles per hour this crew was traveling just 3 hours ago.
Forces, how do you copy me? I am, this is Cratchit.
Я тоже вас принимаю хорошо.
We read you loud and clear.
Автоматически баллистический промах, перелет 4 секунды.
Ballistic miss is 4 seconds. We are in the controlled automatic descent. We see you guys.
Кречет-1, отлично, здоровья.
Cratchit,
Также чувствует себя хорошо.
greetings. Cratchit 1, feeling great. Cratchit 2, feeling good. Cratchit 3, feeling amazing.
Принято, рада слышать.
That is good news, guys.
Confirmation from the crew themselves that they are all feeling good, great, and amazing. The crew also has a voice and visual with the search and recovery forces. Russian search and recovery ATVs continue making their way toward the anticipated landing site.
СС, я Кречет, подскажите высоту.
Cratchit, search and rescue forces, what's your altitude? Our altitude is 3 kilometers, 750 meters. Oxidizer,
Наддув сброшен, 4.
drop.
Да не, он снижается еще. Потихоньку. 1 и 1.
As the crew continues drifting down to Earth under that parachute.
Barometric altitude on the input panel is 3 kilometers.
The next major milestone, and essentially the final milestone just before landing, is the soft landing engine firing. This is when 6 engines will fire to slow the descent rate to 1.5 meters per second, so just over 3 miles an hour, when Soyuz is less than 1 meter above the ground. So the spacecraft now traveling about 16 miles per hour ahead of those soft landing engines that fire just before touchdown to help ease the return to Earth. And a reminder that radio beacon that you hear is completely normal. This is establishing communications, that beacon coming from the spacecraft. You're hearing communications to and from the Soyuz MS-28 spacecraft. Voice you're hearing, that of Commander Sergei Kudzverchkov, Roscosmos cosmonaut speaking with the mission control team in Moscow. Again, conditions at the landing site, visibility about 6 miles with 24 mile per hour winds and 88 degrees Fahrenheit.
This is Precious. I'm getting to 900 meters. Hold your arms close to the body and please do not speak. And this is going to stay true all the way until landing.
Landing now less than 30 seconds away. Crew receiving final instructions as they prepare for touchdown.
Reference altitude, brace for landing.
Touchdown. Chris Williams, Sergei Mikheyev, and Sergei Kudzverchkov have returned to their home planet at 5:27 a.m. Central Time, 3:27 p.m. in Kazakhstan.
Soyuz is on its side, and there is no fire. That's the rescue forces reporting. All right, and the helicopters are approaching to land.
So heard the call that the Soyuz is on its side. This is not uncommon for the Soyuz, and the crew will be extracted from the spacecraft upon the recovery forces arriving at the capsule.
The 241-day mission launched from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan back on November the 27th and involved orbiting the Earth some 3,856 times, travelling more than 160 million kilometres. While on station, the crew were involved in more than 250 scientific experiments, including research on new cancer treatments and improving in-space manufacturing of materials used in high-performance computers and electronics. They also undertook 2 extravehicular activities, or EVAs, NASA spec for spacewalks. These were designed to prepare for station power system upgrades and to replace a faulty joint in the Canadarm2 robotic arm. For more than 25 years now, people have lived and worked continuously in space aboard the International Space Station. The orbiting outpost is helping NASA understand and overcome the challenges of human spaceflight for long-duration missions to the Moon and eventually onto Mars and beyond as part of the Artemis program. However, the space station's future is now limited, with NASA planning to deorbit the 109-metre-long, 420-tonne outpost sometime in late 2030 or early 2031. It'll be replaced by smaller commercial space stations and a major expansion of China's Tiangong space station, which will double its size. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for August on Skywatch. August is the 8th month of the year in the Julian and Gregorian calendars. It was originally named Sextilis in Latin because it was the 6th month of the original 10-month Roman calendar under Romulus in 753 BCE when the year started in March. It only became the 8th month when January and February were added to the start of the year. In the year 8 BCE, it was renamed in honour of the Roman statesman and military leader Augustus, who had achieved several military victories, including the conquest of Egypt during the month. Okay, turning to the heavens, and the constellation Scorpius the Scorpion is high overhead this time of year, covering almost a third of the August night skies. At the heart of Scorpius, located some 470 light-years away, is the red supergiant Antares. A light year is a distance of about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The name Antares means rival of Mars, and indeed when they're close together in the sky, they do look very similar. Antares, or Alpha Scorpii as it's sometimes called, has some 12.4 times the mass and an incredible 450 times the diameter of our Sun, and is one of the largest known stars in the universe. Antares is so big that were it placed where the Sun is at the centre of our solar system, it would engulf all the inner planets, Mercury, Venus, Earth and Mars. Its outer surface would reach almost as far as the orbit of Jupiter. Antares is a binary system. There's a companion star orbiting with it called Antares B, a massive spectral type B blue-white star, at least 7.2 times the mass and 5.2 times the radius of the Sun. It's located about 224 astronomical units beyond the primary star. An astronomical unit is the average distance between the Sun and the Earth, about 150 million kilometres or 8.3 light minutes. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're closely followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Now, each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now, put all that together, and our Sun is a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types LT and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or 0.08 solar masses. Located near Antares is the spectacular globular cluster Messier 4, or M4 for short. Named after the 18th century French astronomer and comet hunter Charles Messier, it's one of a catalogue of 103 fuzzy objects which weren't comets, and so were of no interest to Messier, and so he made a list of them, so he didn't waste his time looking at them. Other astronomers have since added further celestial objects to the catalogue, bringing the total to around 110. Located some 7,000 light-years away, Messier 4 can be seen through a pair of binoculars, making it one of the closest globular clusters to Earth. Globular clusters are densely packed spheres containing thousands to millions of gravitationally bound stars, which it's thought were either originally all born at the same time in the same stellar nursery, or are the surviving cores of galaxies that have been cannibalized by larger galaxies. They're almost always found orbiting the halo of galaxies. The Milky Way has about 150 of them, and they're all usually very ancient, some dating back to around 12 billion years. Located just below the sting of Scorpius are two open star clusters, M6 and M7. M7's the nearer of the two, located about 800 light-years away, while M6 is a more distant 2,000 light-years. Open clusters are less densely packed than their globular cluster counterparts, with the stars inside them less gravitationally bound and more prone to drifting away over time. Another open star cluster in Scorpius is NGC 6231, located about 6,500 light-years away, just near the star Zeta Scorpii. NGC 6231 is a bright open star cluster containing around 120 stars, including a significant population of highly luminous supergiants, numerous white-yellow stars, and at least 2 Wolf-Rayet stars. Wolf-Rayettes are extremely luminous evolved stars reaching the ends of their lives. Having run out of hydrogen for core fusion, they're no longer on the main sequence and are instead fusing progressively heavier and heavier elements in their cores. This causes them to have surface temperatures of up to 200,000 degrees Celsius, and such extreme temperatures generate powerful stellar winds. Just behind Scorpius is the constellation Sagittarius, the half-man, half-horse of Greek mythology. And as we mentioned in last month's Skywatch, the centre of the Milky Way galaxy is found in Sagittarius, roughly 27,000 light-years away. The name Sagittarius can be traced back beyond the Greeks to the ancient Mesopotamian archer god Nergal. Sagittarius is known for its many nebulae and clusters, more than any other constellation. One of the largest and brightest is the globular cluster M22, big enough to be visible to the unaided eye. Located about 10,600 light-years away near the galactic bulge, M22 is more elliptical than most globular clusters. It's located just south of the ecliptic, the plane in the sky upon which all the planets orbit the Sun. and it contains over 70,000 stars, covering an area of around 100 light years. It also contains at least 2 black holes, and is one of only a handful of globular clusters known to contain planetary nebulae, the puffed-off outer gaseous envelopes of dead sun-like stars. Located in the sky next to Scorpius in the west and Sagittarius in the east is the constellation Ophiuchus, the healer or serpent bearer, often portrayed as a snake coiled around a man. In Greek mythology, Ophiuchus raises Orion from the dead after he was bitten by Scorpius. Ophiuchus contains several star clusters and other interesting features, including Barnard's star. Barnard's star is the second nearest star system to the Sun, beaten only by the Alpha Centauri triple star system. Located some 5.9 light-years away, Barnard's star is a spectral type M red dwarf, about 0.144 times the mass of the Sun. Our Sun is around 4.6 billion years old. At between 7 and 12 billion years of age, Barnard's star is considerably older than the Sun and may be among the oldest stars in the Milky Way galaxy. It's lost a great deal of rotational energy, and its periodic slight changes in brightness indicate that it's rotating about once every 130 days. By comparison, our Sun rotates roughly once every 29 days. Given its age, Barnard's star was long assumed to be quiescent in terms of stellar activity. But in 1998, astronomers observed an intense stellar flare, indicating that Barnard's star is indeed a flare star. Flare stars are variable stars that can undergo unpredictable dramatic increases in brightness lasting a few minutes. It's believed that the flares of flare stars are analogous to solar flares in the Sun, in that they're generated by stellar magnetic energy stored in the star's atmosphere. Lying just to the west of the Scorpion is the constellation Libra, the Scales. In Greek mythology, Libra represents the claws of Scorpius the Scorpion. However, the Romans considered Libra a distinct separate constellation from Scorpius and thought them to be the scales symbolizing the equinoxes, the times of the year in March and September when the Earth gets equal lengths of day and night. That's because 2,000 years ago, when all this was made up, the Sun moved into Libra at the time of the September equinox. But due to precession, as the Earth's spin axis wobbles in direction, this point in time has now moved into the adjoining constellation of Virgo. If you look to the south in the Southern Cross, that's the constellation Centaurus, another half-man, half-horse mythical beast. Centaurus was the teacher of many of the Greek gods and heroes. He was placed among the stars in the heavens after accidentally being killed by a poisoned arrow fired by Hercules. Close to the pointer star nearest the Southern Cross, Beta Centauri, lies NGC 5139, Omega Centauri, the largest and brightest globular cluster in the visible sky. Because of its brightness, the ancient Greek mathematician and astronomer Claudius Ptolemy originally thought Omega Centauri was a star. It has a diameter of more than 150 light-years and contains an estimated 10 million stars, giving it some 4 million times the mass of our Sun. Located some 15,800 light-years away, Omega Centauri is another very ancient globular cluster, around 12 billion years old. And it contains many so-called population 2 stars. These are the second generation of stars to have formed, and were created directly out of the remains of the very first stars in the universe. Stars in the core of Omega Centauri are so crowded, they're estimated to average only 0.1 light-years away from each other. And that compares to the nearest star to our Sun, Proxima Centauri, which is some 4.2 light-years distant. Located close to Omega Centauri in the sky is the giant lenticular galaxy NGC 5128 Centaurus A, which we see looking like it's split in half by a thick band of dust. The galaxy was discovered in 1826 by astronomer James Dunlop from his home in what is now the Sydney suburb of Parramatta, a time long before the bright lights of a modern city would make such a discovery impossible. Located some 13 million light-years away, Centaurus A is one of the strongest radio sources in the sky and is thought to be the result of a merger between an elliptical and a spiral galaxy. It can be easily seen using a pair of binoculars, but you'll need a telescope to make out its spectacular dust lanes. August is also the time of the peak of the annual Perseids meteor shower. The meteors are the debris trail ejected by the comet Swift-Tuttle as it travels along its 133-year orbit through the solar system. As its name suggests, the Perseids radiant, that is the point of the sky from which the meteors appear to originate, lies in the constellation of Perseus. The Perseids are one of the oldest known meteor showers, with early Chinese historical records of its activity going back almost 2,000 years. They're active between July the 17th and August the 24th, with a peak on August 12th with around 60 meteors an hour being visible. The Perseids are very bright and fast-moving meteors, travelling at speeds of 59 kilometres per second. They're best seen between midnight and just before dawn, producing long, bright trails and some fireballs. Most Perseids burn up in the atmosphere at altitudes of over 80 kilometres. They're best seen from the northern hemisphere, so for southern hemisphere sky watchers, look to the north with the radiant below the northern horizon. And joining us now for the rest of our tour of the August night skies is senior science writer and Sky and Telescope magazine contributor Jonathan Nally.
G'day, Stuart. Well, it's winter here in Australasia, so that means that stargazers down here have at their disposal the thickest part of the Milky Way and the centre of our galaxy to view up there in the night sky. So if you go outside in the mid-evening during August, you'll find the Milky Way stretching across the sky from the northeast all the way down to the southwest. And the centre of the Milky Way, in the region of Sagittarius, is pretty much directly overhead for those at roughly the latitude of Sydney. The Milky Way, of course, is just our galaxy seen from the inside. Most of its stars are too far away and dim to be seen individually, but if you add them all up collectively, light adds up to form a sort of hazy band of light stretching across the sky. It looks really bright and prominent if you have dark skies, if you're out in the countryside and you've let your eyes adapt to the darkness, to the night sky. It takes about 20 minutes or so to get your eyes dark adapted. So if you're out there in the bush or a desert or a rural area, if we call it the bush in Australia, then you should get a really nice view of the Milky Way. If you have even mild light pollution around, then it starts to drown out the haze of the Milky Way, so it might be very dim or hard to see. And if you live in heavily light polluted suburbia, well, just forget it. You're not going to see the Milky Way, which is a real shame because when I was growing up, you could, even in suburbia, because there weren't so many lights around. In fact, I remember when I was growing up in the city, I was in too many decades ago to mention, they used to turn all the street lights off late at night. I think partly because there were very few people driving around, and also at the time I think there was a bit of just a general power shortage in our state. They needed to build more power stations and things, so they used to conserve a bit of energy and save a bit of coal and turn the lights off late at night.
When you were in Melbourne or when you were on the New South Wales?
Yeah, that in Melbourne, Melbourne and Victoria,
we never had that in Sydney. They were onto the milkman came in the morning.
Yeah, I think in Melbourne at the time, Melbourne got a huge influx of migration after World War II, and stacks and stacks of people, and it was growing very quickly, and they just needed to build some more power stations, and they turned the lights off just to conserve a bit of energy, I think, and I remember blackouts when there simply wasn't enough power. But anyway, it's getting a little bit off topic there. Well, blackouts are good for stargazing, of course, but not good for other things. So where were we up to? Well, anyway, so centre of our galaxy is a really good thing. It's a focus of a lot of attention for astronomers, actually, and it's one of the reasons why there are so many professional and semi-professional observatories located in the southern hemisphere, because when we look in the direction of our galaxy's core, we're actually looking through the densest and deepest section of the Milky Way. So there are lots of things to see. What astronomers call deep sky objects. You've got star clusters of both kinds, open and globular. You've got bright and dark nebulae galore, and of course for the professional astronomers who've got the right sort of gear to study it, they can look right into the heart of the Milky Way, into the area where the black hole is that lives right in the core of our galaxy. Our friends in the northern half of the sky, say the United States, here in the southern United States, you can certainly see Sagittarius and see most of it there, but the further north you go, it starts to either get really low on the horizon and hard to see, or even below the horizon if you're quite far north, because it is a southern constellation. So, it's a lucky thing for us down in the southern hemisphere that we've got the centre of our galaxy nicely overhead. That's partly because just where it is in space compared to us, and of course the tilt of our planet. So we're a bit lucky in that way. Now, further down in the south, we've got the other famous thing that you can see down here, which is the Southern Cross. It's in the southwest at the moment, about halfway up from the horizon and lying on its right-hand side. The Southern Cross area is within the Milky Way, the band of the Milky Way, and stretching away from the cross in a line northwards along the Milky Way, there are lots of other really interesting constellations to have a look at. Constellation is just an area of the sky. In the old days, the constellation was like a stick figure arrangement, join the dots of stars and it makes a triangle or this or that or an animal or some some kind or other. These days, as far as astronomy is concerned, it's just an area of sky. But there are lots of interesting constellations along there. You've got Centaurus, which is near the Southern Cross. You've got Scorpio. You've got Sagittarius, we've mentioned, and another one called Scutum. Now, not a lot of people outside of astronomy have heard of Centaurus, and fewer still have heard of Scutum. As the name suggests, Scutum is named after a scooter, but it's not the kind of scooter with two wheels that cool people like me ride around on, Stuart. No, it's named after a scooter, S-C-U-T-A, which is a Latin word for the type of ancient Roman shield. And Scooter is constellation. Scooter is the constellation of the shield. Now, if you're out there stargazing for long enough, as night goes on and the Earth turns, you'll notice that from our vantage point, the band of the Milky Way appears to shift. So I said earlier on that it's stretching across the night sky from the northeast to the southwest. Well, as the Earth turns, the Milky Way in the night sky seems to move as well. So by the time you get to early morning, it's no longer right overhead. It's now all the way around the horizon. And that's just simply because our viewpoint has changed. And then the next night, of course, as the Earth has turned some more, it'll be back in roughly the same part of the night sky. Now, if you're a morning person, there is plenty to see, particularly in the eastern half of the sky. And this includes the constellation Orion, the Hunter, with its bright stars Rigel and Betelgeuse. And it's very easy to see a group of 3 stars in a row, which form the belt of the mythological figure's clothing. Now, I always remember as a kid that these 3 stars stood out. I didn't know anything about astronomy really or constellations and things back then. I just viewed it as this part of the sky where there is really 3 stars in a perfect line, perfectly sort of equally separated. And I always just look for them. And now I know, of course, that is part of the constellation Orion. A little away from Orion, not too far, around to the right or the south, you'll find Sirius, which is the brightest star in the night sky. And further around to the right, you've got the star Canopus, which is the second brightest star in the night sky. Canopus is quite deep into the southern part of the heavens, so a lot of people north of the equator don't get a view of it at all because it's down below the horizon for them. Now, as far as the planets go for August, this year at least, there's only one we can see actually in the early evening sky, and that's Venus. You simply can't miss it. Wait till it starts to get dark when the sun's gone down, and look in the western half of the sky, and there it is, big and bright. I was looking at it just the other night, and it's really quite spectacular. In particular, have a look on the 16th if you can, the 16th of August, if you've got clear weather, and you'll see Venus and the moon quite close together. That should look pretty spectacular. Getting closer to midnight, there's a second planet now, so we've got Saturn rising over the eastern horizon around about midnight. It just looks like a fairly bright, slightly yellowish star. If you can get a telescope onto it, even a small one, you'll be able to see the rings, and that's always pretty good. Saturn never, ever disappoints. You have to wait until about 4 o'clock in the morning until the next planet makes an appearance, and that's Mars. It will come up over the horizon just after 4 o'clock. It looks like a sort of a reddish-orange medium brightness star. I say it looks like a star. It's not a star. It looks a bit like a star. And the only other planet around at the moment that's easy to see is Mercury. But I say easy to see, but actually is quite hard to see at the moment. And you only have a week or so to do so. So you need to look into the orange pre-dawn glow before the sun rises and try and pick it out low on the horizon. For just the first week and a half of August, it'll be quite low down, look like a tiny pinprick of light within the pre-dawn glow. It's hard to see Mercury. A lot of the times when it is above the horizon, it is not high above the horizon and not particularly bright, and it can be obscured by trees or buildings or whatever because it never really gets too high. Other times of the year, it can actually be reasonably prominent and you can see it quite easily, but no pun intended, Mercury can be a bit mercurial. It's not the easiest planet to see. That's because it is so close to the sun. It never, what you might call an angular distance away from the sun in the sky. It never gets very far from the sun. So you either see it just before dawn or just after sunset, and it's a bit of a harder target than the other planets. But anyway, that's the night sky for August, Stuart.
That's senior science writer and Sky and Telescope magazine contributor Jonathan Alley, and this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.